Hello all, welcome to session 16 of the PySpark series. So in last session, we have seen how to filter the data using PySpark. We have not yet seen Spark SQL, okay, but it is similar to the normal SQL that that we use, okay. So what we have seen is the multiple ways to solve one problem, okay, and now we will see which is the efficient way, right? Uh, from the uh, multiple methods we have used to solve the problem. Okay. Also, we have seen the ends with I couldn't say ends with function, starts with function, between function of PySpark. Okay. Now, hmm, for first problem, okay, we have seen I think these three ways we have used to solve this problem. Okay, and as I have already told you, okay. Uh, Wherever you use expression, for example, this is like an expression, right? So wherever you use an expression, for example, this one, then these two, right? It kind of a SQL expression. Again, this one, okay, and this one. So these are SQL expressions we are using, okay? So SQL expression basically needs one more step, one extra step when it comes to processing in Spark. Okay. So what happens is this SQL expression needs to be converted to column object so as to move to further processing in Spark. Okay. For the processing, there are various plans we will see going ahead that gets created in Spark. Okay, what is the importance of these plans? For example, logical plan, then we have analytical plan, parse analytical plan, then physical plan, right? We will see importance of all these plans going ahead. But as of now, just keep in mind the approach using the Python approach. Okay, the more programmatic approach is the efficient approach when it comes to um, efficient code writing. It the parsing step. Okay, it does not need any parsing. It directly can go ahead and participate in the further processing that happens in Apache Spark, the plans that get created in the Spark. Okay, fine. Now I also told you that we will understand if there is any performance difference in filter and where. Okay. So there is no major performance difference when it comes to filter and where. Okay. Where is like most likely a kind of we use same in SQL also, right? For filtering. Okay. So in filter and where there is not much performance difference, okay, but it is suggested as a good practice when we use complex conditions, okay, when we have multiple conditions in place, filter might be slightly faster, okay. It is not proven that filter is faster when we have multiple complex filter conditions, but it can be little faster than where, but the performance difference is not that noticeable. Okay, so both of these are equally performant, but filter sometimes can be more performant. Okay, fine. Uh, Now, one more thing I wanted to show you just for good practice. I think just a second. If I can show you through these examples, what whose name starts with one, ends with one. Fine. Uh, let's say we consider one more problem statement. Okay. Let me go to the end. Okay. Fine. Let's say we have one more problem we have to solve. Uh, Find, let's say, a filter. For example, filter employee where employee IDs are, let's say, EMP1, EMP21, EMP32. Okay, random I'm taking EMP32, EMP43. So there is something I want to filter only employees whose employee IDs are these. Okay, so Um, how how I can approach this problem? What I can do? Let me create empdf1 here. Okay, emp. So empdf we have already created. Okay, I'll just show you empdf first. Empdf dot display. Okay, this is our employee data frame that we have created, right? Okay. Now what I have to do is emp df1 equals to emp df dot filter. Okay. What I have to do? Let's say a programmatic approach I'm taking. Emp name. Okay. Dot in is in what? This list. Okay. So what I'm doing, I'm specifying the list here. Okay. EMP1, 21, 32, and 43. Okay. EMP1, okay. EMP21, okay. EMP32, okay. And EMP43, I think it is 43. Okay. 43. Right. So in cases where I have to have such problem statements, okay, where I have to, let's say, filter employees whose employee IDs are from this. Okay, so let me run this. Okay, let me display emp df1 dot display. Okay, emp df1 dot display. So we can see we have got all those employees where employee names are between, you know, in the list that we have specified. Okay, now why I have taken this problem is I wanted to show you that this list basically, when we work in project, if we have requirement that this list we are using at multiple places. Okay, for example, this list this is like, let's say, a list of employees who are some, let's say, um, what I can say, outperformant employees, good performant employees, and that may change, okay, every quarter or every month, right? And you have some code written to filter the, let's say, outperformant employees, and you want to give them some price in that month's salary, right? Let's frame some problem, okay? So this list, if you are using at, let's say, 10 places in your code, okay, um every time you cannot go and change this list at 10 places in your code. Okay, what will happen is that will, let's say, um, add extra effort for a data engineer, for data developer. Okay, and also it may lead to some manual error in some place. If, let's say, if in one place from 10 out of 1 out of 10 places, if you miss to update the list, that may run your program, wrongly, right? So what we do generally when we work in project, what we do is we define, let's say, a list, okay, at one place, let's say in some configuration, right? Employees to, let's say, award. Okay, this list, let's say, I have defined. Okay, now let's say this list I have to use at 10, 11 places in my code. That is fine. Now it is like I just have to change at one place where here, and I can use it any number of places in my code. Okay, how to use that? I'll just show you. F.col emp name dot is in what, this list, this Python list I have to specify. Okay, employees to award, right? If I display this empdf2 dot display, okay, right, it has filtered the expected employees, right? So what I wanted to convey is, uh, always when you are working in the project, make sure you write your code in such a way, in such a dynamic way that it needs a little maintenance. Okay, going ahead, if you want to change this list, let's say monthly, okay, you can just see, you can pass it through, there are many ways you can pass it. Okay, you can pass it through parameters in databricks only. Okay, so there are many. Let's say you are passing this list every time from some parameter. Okay, so if it changes at this place, it will be changed at all 10 places in your code without touching the code. Right, it's very important to not touch the code again and again so as to avoid manual error. Okay. Okay. This I wanted to explain. I think it's a basic and very important best practice that we follow. Okay. Fine. Hmm. Okay. Now, again, I think we remained with Spark SQL. We wanted to solve all these problems using Spark SQL. Okay. So let me quickly do that. EMPDF, I have what I'll do. I'll create or replace temp view. Now, so far, you know what why I am using create or replace temp view. Why not create or replace global temp view, right? Because I want this employee view only to be used for this particular Spark session. Okay, fine. What's the first? Filter the employees whose salary greater than 24,000. Okay, Spark SQL, very simple. It is like MySQL, right? Select star from employee where EMP salary greater than 24,000, right? And display. Okay. Why display? Because output of every Spark SQL is again a data frame. Okay. Right. Very simple. That's how we achieve the first, I would say, um, the first question that we had, right? Now, next is filter the employees whose name ends with one. Okay. Whose name ends with one. Let's try to solve this. It is again the like operator. We have done this. Well, this one, right? It is like we have said this is like a SQL expression. Same expression we'll use here. Okay. Select star from employee where EMP name like what percent one ends with one, right? Percent one. Whatever has to come before one, I'm okay, but end should be with one, right? Display, right? So again, the results are same as same as the PySpark query that we have used. For example, this query, this line of code in PySpark, but what's the difference? Difference is Spark SQL, it has to parse to column object before it goes to logical plan. Okay, logical plan of PySpark. As of now, we will say further processing in PySpark. Okay. Next, what is this? Filter employees whose employee ID is between 34 to 67. So this is SQL expression we have used. Same we'll use here. Okay. Spark.sql select star from employee where employee ID between 34 and 67, right? Display, right? Done. So all the employees whose employee IDs are between 34 to 67, we have got the output. Okay. The same output what we have got with this PySpark code, we have achieved using SQL. Okay. Again, we will prefer PySpark data frame so as to skip the parsing step. Okay. Uh, and next is what I think the next problem it's the same. We have used, right? For example, employee ID in this list. Okay. So how to solve this in Spark SQL? Employee name, spark.sql, select star from employee, where employee name in what this. I have to give single quote because I have used double quote at the, for this Spark SQL, right? And the bracket is missing, right? Fine. Dot display. Okay, fine. So this is how we can solve all the, you know, mm, uh, like to filter the data. We have filter and where transformations in PySpark. Okay. Again, what is transformation? Transformations. There are multiple transformations in PySpark which we use to achieve the desired output. Right. For example, filter. We are trying to filter the data. Okay, and to use it for further processing. Right. What is transformation? Basically, transformations are lazy. As soon as you hit the transformation, for example, if I hit only this transformation, my data frame, or there will be no materialization that will be happening. Okay, it is not materializing. That means no data movement is happening. Okay, but if I say display, then there will be data movement. So all the internals also we will see going ahead. Just as of now, keep in mind, transformations are lazy. Actions are not. Actions are not lazy. Okay, display is an action, right? Display is an action because it is giving the results to Spark driver, and that's why we are seeing here. Okay, the output. Fine. So this is about, I would say, the filtering data in using PySpark data frame and Spark SQL. We have understood what methods or what way of coding is efficient. How can we skip the passing step, right? So as to make our code more and more efficient. Also, we have seen in filter where there is not huge performance difference, but filter may be efficient when we um, work with complex queries, when we have multiple filters in one query, multiple filters. Let me show you how we can have multiple filters in one query. For example, let me take this. Okay, let me take this. Okay, empdf9 f.col emp id between 34 and 67, and let's say from this I want to find out what I want to find out. Emp name dot is in my the list that I employees to award. For example, let's say I have this. Okay, so empdf9 dot display, right? So between 34 to 67, I have only 43, which is in this list, right? So this is how we can specify multiple, multiple filter conditions, right? Fine. I think that everything for this session. We have completed, we have seen how to filter the data in PySpark using PySpark data frame and Spark SQL. Okay. Fine. If you feel this is useful to the community, do like, share, subscribe. Okay. If you have any suggestions or feedback for me, do let me know in comment section, or you can ping me on LinkedIn one-to-one, right? That is also fine. Thank you so much for watching. I'll see you in the next session.